Welcome to a new test and teardown video. This time it's one of those all-in-one test systems. This one is from Voltcraft Universal System MS-9150. I think it is manufactured by Metex Instruments in 1994, because I found schematics, and that is what I find in the schematic, of course. This thing is quite big, and it's also quite heavy. It's 13.5 kilos, but I think there's a pretty good reason for that. It consists of a power supply with 3 outputs, individual outputs. You can series those or use them individual, whatever you like, right? And one of them is a variable 0 to 30 volts, 2 amps. So that is a nice power supply. We got a 5 volt and a 12 volt output, volt amps and all that kind of stuff. And we got a function generator with all the fancy smancy sweeps, and yeah, it's a full-blown function generator. But there's also a frequency counter with 3 different inputs. So I think it can do time between A and B, and it can do frequency. It will do all sorts of stuff. And this is fully microcontroller controlled. So you can see we got those push buttons like that. And that is because everything is microcontroller software. And we also got a digital multimeter. And it will do all to 20 amps. And it says 1000 volts DC. So you got everything in one unit. You can measure capacitors. And there's even, look at that, a little battery in this unit, so you can use the voltmeter without turning on anything else. That's quite nice. I just took it out because I wanted to find the power entry, and yes, it is correctly set for 240. I think, no, it is not. Is that a little pointer up there? And I think, yes, I think I will fix that. So we also got an RS-232, and this is for the digital multimeter. We got 2 optocouplers in here, and it will just output data from the multimeter. We got the function generator on-off is here, and frequency counter on-off. So that's just something you need to remember, because you don't find those switches on the front. And look at that. Huge heatsink for the power supplies. I was told this unit should work, so I don't expect to see any kind of kabooms. But nothing works. Damn it! What did I do wrong here? Oh, yeah. So we're back. Now it works. I rotated the voltage selector switch back to 220, and now it works. So there's a broken connection in 240 volt mode. It just don't power up. It is as simple as that. Oh, that's funny. So when you turn off the power supply, you also lose power to the frequency counter. Why is that? I mean, really? Why can't you just... So that is the frequency counter, right? So now it's turned off. And that is the power supply. And then So that is definitely how it works. And I don't see any kind of indicators on the function generator. But how about if we connect the function generator to the frequency counter? Should we be able to those. Oh, those. Now they work. Yeah, definitely some sticky switches. I think I am able to show you a little scope picture of the output at the same time, right? There's something wrong with the frequency counter also. If I go to channel B or C here, I mean no response, so I need to be in channel A. And I think also this little here, it says display, frequency counter, or function generator. So if I plug this in, the display up there will of course automatically just show what is the frequency of the function generator, right? But that I don't want. I want to measure the output myself and then have a look at the output with a scope at the same time. So that is my whole idea. So look at that. This is a very low frequency because we are now in ×1, so it's 1 hertz. That seems to be working, but if I go faster, just one click, this is 144 kilohertz and it's completely unstable. And this is more or less the same. This is now megahertz, depending on how I clickety-click. See, it's completely, and then nothing. So that means the function generator is just completely dead in all the switches, no matter what I do. This looks like a mechanical issue, but it's, how can it just go to the same frequency, either 3 megahertz or 177 kilohertz or something like that, instead of the correct, except for ×1. I mean, what the heck is going on? And also, if I look at the curves here, it's, look at that, how bad it is. Something is completely wrong. Square wave, yeah, okay. But it's just bad in any possible way. And then again, now there is a frequency of whatever kind of kilohertz. And I put this into, at the moment, channel A. So the idea is to click channel A like that. But then there's also another little thing. You can't change that, I guess. It's gating over 10 seconds. And then it says 200 kilohertz and the average is 144 kilohertz. So not even that works. It's just completely... Okay, so it can also do that. A, B, la 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 la. We can count, but it's frequency I want. Yes. Alright, so far all this here is just completely not working. So let me do all the figuring out what is working and what is not working before I open it. I think that is the most fun to do. So what is that voltage? Okay, let's go to voltage. Okay. See? I can actually adjust the voltage. So it appears. Ah, this is a nice multi-turn. And how is, okay, current is not a multi-turn, but voltage is a nice multi-turn. I'll try and see if the power supply works. Okay, so the power supply appear to be working. And so is the voltmeter is okay. But the internal voltmeter here is a little bit off. I think I can probably calibrate this. There will be some trimmers in here, so let's try and load it a little bit. So here we go. That is 1 amp. And if I take the current limit to the about center point here, see we go in constant current mode. So that means the 0 to 2 amp works quite well with the meter here, or this potentiometer here is about in the middle for 1 amp. I kind of like that, so that is hereby approved, and the amp meter is also accurate enough to the last digit. So far so good, right? Maybe we should try and see if it can really do the 2 amps. It's not in current mode. So let's see if it can. Yes, exactly. So it can give you the full. Let's give it full juice. So that is 60 watts of output, and it is using 120 watts. I did not expect that at full output voltage. I mean, really? If you don't believe me, here you go, 120, right? So what we could do is, let's just try and turn this off. And what is, okay, it's the idle power of this entire unit here is 28. That is also some kind of power, isn't it? 28 watts. The power supply module here is not just the power supply. It's also all the auxiliary power supplies for all the other units. So that explains why the power supply needs to be on, and then you can turn the other units on. I think it's also because it comes from the same main transformer, but there's actually also another transformer, so I would imagine that it was an idea that you could maybe turn on and off something individually, but that's not exactly what I see. So that will be, yeah, I think I can see a little line down here. So I think we've got a lot of the auxiliary supplies here for a lot of all the other things. Down here will be the function generator, and up here is the frequency counter. And I want to show you a few cool things on the frequency counter. Yeah, I was right about this Metex, and it seems like this frequency counter is an updated version. See, this one is from 96, and the schematics I found, they are from 93. And here we got some frequency counter chips and a microcontroller that is doing all the fancy smancy stuff. We got a high precision temperature compensated oscillator, 10 megahertz. So that is really good. I really like when it's 10 megahertz, because that means you could, use external input and stuff like that. This display here is, of course, multiplexed, so that's why we got all those different transistors to turn on the common points of each 7 segment. And here you got the segment drivers, and there's a little funny thing. Look at the resistors. Oh, that's funny. So somebody choose to use resistors that's just way too big. So you see, some of them need to go a little bit up, because the layout was made for 1/4 watt resistors, and what you have here is 1 watt resistors, or 1/2 watt. At least they are way bigger. So that's a little bit funny. And since we don't have any input, when I actually did see that I have selected the right input, that means I need to open the input box and see if I can measure where's stuff missing. So maybe somebody input some, signals way too powerful or something like that. So I think I will go and see if I can figure out the frequency counter first, and then I will have a little look at the function generator. Oh, you gotta see this. Of course the frequency counter works, Well, with an external source that is nice and stable and all that, it really works. So here's the funny thing. This is 120 megahertz, so it's 20% more than official rated input is 100 megahertz. So this is channel A, and now the LED here is A. So the idea is you push this channel switch, doot, now it's B. And if you have bad eyes like I have, you would obviously think that, okay, this is A, you can read that, then you don't worry about, you will think that this is B. But now I found the good glasses, and I can of course easily read this is B. How stupid is that? So channel B is here, right? A, B, C. And then why that? Who came up with this absolutely idiotic front plate design that is just bad? I mean, it could have been A, B, C, and A, B, C here, and that wouldn't have costed them any kind of arguments with anybody, right? Oh, that is funny. And the C input is in the middle. Down. And then it goes. And of course you can gate different timings and get higher and higher resolution and all that kind of stuff. And now we are of course in the 1.3 gigahertz input. So here's the C input. I was so close to saying B. And it's officially rated to 1.3. Oh, my bad. Let's give it a little bit more then. 1.3. And let's see. Yay, it works. And of course you cannot have higher resolution here. You cannot gate more gate time because we got no more digits for some reason, as you can see here. All right, so if we go to 10, no, that should be possible because it's 8 digits, right? Shouldn't we be able to see that happen? Yes, we did. So there you have it. The frequency counter in the C input can only show you a little bit more than the official 1300. But it does go a little bit over, so that's perfectly fine. Alright, so I'm not going to play so much more with the frequency counter since it seems to be working quite alright with an external source. What I can show you is how it's designed. So that will be the A input, and the A input got a little input attenuator, that is that relay, and then it switches in some resistors and all that kind of stuff, and that seems to be working as well. We've got a little amplifier and I think a little divider, and that is of course the high frequency input prescaler, and it's exactly the same in the other input here, right? Yeah, nothing gets warm or anything like that, so fantastic. I just can't stop playing around with this frequency counter. It is a lot of fun. It's actually really amazing. I just give it 1 hertz at the moment. It is a little bit confusing because it is auto ranging and all that kind of stuff. It can do a lot of cool things. So 1 hertz is not so cool. Let me give it 10 hertz instead, and then it goes nice and stable. So there is something with that. Then you should of course do something else with yeah, that is definitely the way. Then you measure the time instead of the frequency, and then it goes nice and stable when you go real slow. So now we can try and give it 1 hertz, and then you will see. No, you will not see. It is obviously a little bit below its... so that is 10. Okay, so it works with 10 hertz. That is just how it is. and then it is nice and stable, and we got quite a lot of digits, and you can obviously give it 10 hertz frequency counting time, and maybe you will be able to give it a digit more, but don't. Yes, you can. Holy moly. It is really, really accurate. I am a little bit impressed, to be honest. I didn't expect that. Well, I think I will call the counter absolutely tip-top, nice and useful. And then I'll see if I can get something good out of this the function generator. Look at that. I was right. It was only a mechanical issue. So this is the function generator. And those switches there, they are famous for creating all these kind of problems. But obviously, this thing is, what, 40 some years old. And those contacts there is, let me show you. There's a tiny little hole up there. And if you flush in there your contact, that hole up there, and then massage all the switches a million times, what you get is a nice and stable sine wave, or different frequencies. I will show you. This is 1 kilohertz and 10 and 100 and so on. Oh yeah, here we go. A little bit of a bandwidth thing in the top level. But all ranges, they are now working. Oh, that is also some goody. What you should see, this type of sine wave generator. I don't know if I can show you this, but try and look at the tops. Can you see there's a tiny little pointy? I don't know. I think it's actually more visible here at the bottom. Can you see there's some little misalignment? I don't know if it's only me who can see that, but this tiny little bit. See, here is this tiny little bit shown using a PC program called ARTA. It is the software analysis software for sound cards. I use an external USB sound cards, 24 bits, super duper high resolution and all that kind of fancy smancy stuff. And it got balanced input, and I'm using a transformer and all these fancy things. But it will let me make a nice frequency sweep and show you the total harmonic distortion. That is the red number to the bottom left. And it will also show me the levels of the harmonics and how many and where they are and all these things. So that is a very useful tool. So of course now the frequency generator is working. I can of course connect the output to the input of the counter unit, and then I went to the fast gate, as you can see here, and now see, I can easily tune the frequency like that. There's another really cool feature. When you know the output is working and you want this to go somewhere else, then you hit the display down here, and now the display will show you the frequency of the generator. So that's very useful. But of course I wanted to make this connection to prove I had a valid output in that cable, right? And here is the backside of the voltmeter unit, and see how annoying that is. They packed it into some plastic here, but I think that is because this whole unit is completely isolated and floating. And what if you connect this to some high voltage and then you stick your fingers in here because you want to do something else, right? So there's nothing really special and funny to look at that. I was looking for the trimmers for the voltmeters, but maybe it has something to do with that, right? See, because that will be the output, the readout from the power supply. So I would expect it to be some of these. I think I'll try and consult the really bad quality schematic I got. Maybe I can figure this out. Here is the schematic to the power supply. As you can see here, the trimmers we will find on the power supply, that has something to do with 0 volts and maximum volts and the offset and all those small things that is not really interesting when it comes to calibration of the voltmeter readout. Here is the schematic of the voltmeter. And as you can remember earlier in the video, we tested the voltmeter reads out too much and the amp meter reads out perfectly fine. The only problem is there's only one tiny little trimmer on this board, and that one affects both the readout of amps and volts. So what do you want? I want accurate volts. I mean, that is the most essential thing, and this is what I use all the time. So I want to adjust the volts, and then, I mean, I will then accept that the amp meter will be a little bit off. I think that is more important. So that is what I do. And to try and show you, here we are, right? And here is the amp meter. So I want to try and show you where is the trimmer for the voltmeter. And now we fly in here and then we zoom in. Let me see if I can get a little bit of light as well. Now we are looking behind the blue wire right now, but on the bottom back, can you see there's a tiny little hole? I don't know if that is visible, but it is possible to get a screwdriver in there and wiggle around and get a good adjustment of the voltmeter. And like you can see now, we have an agreement, and I can of course set my volts to whatever I like. And then, oopsie, why did you do that? And then everybody's happy again. So this is what we want. We can also very quickly, as the last little tiny, see, that is the capacitance, and then it just goes. This should be 1 microfarad, by the way, but so it really is very useful for a lot of things. Maybe you should get one of these all-in-one measurement stations, and yeah, you have a whole lab in one unit, more or less. So thank you very much for watching. I hope you had a little bit of fun. See you soon again. Bye bye.